Okay, 2.5 inertial and non-inertial frames of reference. So to describe that, describe inertial frame of reference. Imagine a bus. The ball is, there is a stationary, the bus is stationary. Of course, the ball is stationary. Also, when the bus is moving with constant velocity, this ball will be stationary. It's not going to move. It's just sitting on a floor and still. The bus moving in constant velocity. So any of this situation that the bus is moving and bus is moving with constant velocity is a inertial frame of reference. Non-inertial frame of reference is a frame of reference that is moving with acceleration. Okay, to imagine that, imagine a ball inside a bus and the bus moving with constant velocity. So the ball is going to be still here. But imagine when the bus will stop. So it decelerates, slowing down, right? When it slows down, it's moving with some acceleration. And the ball will force forward, move forward. Okay, why that happening? Just imagine yourself in a car and suddenly the car is stopped. Of course, you lean forward. You feel a force push you forward. Also, when imagine you're in a car and it accelerates, you feel the force backward, right? Suddenly, if the car is moving forward, you feel backward. So these are the fictitious forces that you feel. The reason is that when you're in car and car moving with a constant velocity, you're moving with constant velocity with the car. When the car is decelerate, stops, your body is still wanna move forward. But since it is stopping, so you feel a force forward because your body tend to move forward, but suddenly your frame is not moving, right? So that's why the fictitious force push you forward. The same thing when the car is start moving, your body is still wanted to be still. When it's accelerate forward, your body want to stay, but in the same position. That's why you feel a force backward. So these forces are fictitious forces. Just look at this question. Draft PT for a ball in figure 1 and figure 2. So for in figure 1, the bus is moving with constant velocity. Just the force normal and gravity acting on it. For the one that is accelerating, the bus stops. The fictitious force is forward. And again, we have F of N and F of G. So look at this question. Teachers suspend a small rubble stopper from the roof of a bus as shown in figure from the chapter opener. Okay, the suspending cord make an angle 8.5 degrees from the vertical as the bus is accelerating forward. Determine the magnitude of acceleration of the bus. So since the bus is accelerating forward, it will be pushed to the back. So this is fictitious force. We just put all of the forces. So if this is the thread and this is the object here, and this is the angle theta. So the forces is force of the gravity downward, F of G. We have force of tension toward the root, F of T. And we have, because this is with this angle, this tension force is going to be your fictitious force. So first, force of tension has two components. The X component, so this is theta. This will be theta too, right? So here it has X component, it has Y component. So X component and the Y component, F of T X. And here's F of T y direction. F of t in y direction need to cancel with f of g. And because it's not going up and down, but since this is accelerating forward, there should be this forces in x direction should be equal to what? M of a. I'm gonna just do that here. Total force in y direction should be 0 because it's not accelerating up and down. So what I have f of ty. Make sure f of ty is what? You look at this. The opposite is f of x and adjacent is f of y. Adjacent is cosine. F of t in y direction is equal to f of t cosine theta because that's adjacent. And f of t in x direction going to be f of t because opposite is x component of t sine theta. Now f of y in y direction is going to be 0, so it's going to be f of g, which is negative, is equal to mg, right? So f of t in y direction is positive, which is f of t cosine theta. This is your y component of f of t, minus f of g, which is mg, should be equal to 0. If you rearrange it for f of t, mg to the other side, and you divide every term by cosine theta. Okay, so there's a y component. Now for x component, we know that total force in x direction should be equal to m of ax. Ax is the acceleration of the bus. Total force in x direction. So what we have is just x component for force of in x direction. So it's f of t. You have f of t sine theta is equal to m a in x direction. So instead of f of t, I can put mg cosine theta, right? Mg cosine theta sine theta equal to max. M and m from both sides cancel. Sine over cosine is tangent. So ax is g tan theta. So theta, we have g is 9.8. Theta is 8.5. You put that in the calculator, you'll get 1.5 meter per second squares acceleration of the bus. Now the question you can do is number 3 for A and B. You try that, and that would be it for this topic.